Welcome to Math 2320, Section 4.9 on linear systems. The concepts in this particular section are not extremely difficult. What is difficult is the amount of details, the ease to lose a constant, a plus or a minus. So try to be extremely vigilant because it's going to make your life a lot easier. All right, so starting off here in question 1, we have this system of equations. The idea is to think of the derivative as an operator d, which we have seen previously. And now I'm going to move everything on the right hand side to the left hand side. So that would give me the derivative of x minus 4x minus 7y equals 0. Similarly, the same for the second equation, minus x plus 2y and the derivative of y. Next, I want to group together the things with x's in it. So this is really d minus 4 times x minus 7y equals 0, and on the second equation, taking out the y, I've got a d plus 2. So now I think of this as a system of two equations and two unknowns, where the unknowns are x and y. So in the first case, I'd like to try to get rid of the y terms. So looking at the y terms, I've got a minus 7 and I've got a d plus 2. So I'm going to multiply the top equation by d plus 2 all the way across. So here is that d plus 2 all the way across. And on the second equation, because this has a minus 7, this one needs a positive 7. And so there's that 7 all the way across. At that point, the y terms go away, and I have something only involving x's. If I group together this minus 8x, this piece, with this piece, I get a minus 15x. This piece now is my constant coefficient, second order, and so I get m squared minus 2m minus 15 with two roots of 5 and minus 3. They are distinct roots, and so we get the solution for x of t. We go back to our system of equations, and I now want to get rid of the x terms. Well, I'm focused on what do I have there? Well, I've got a d minus 4 and a negative 1. So I'm going to leave the top equation alone. I multiply the bottom one by d minus 4, and that's all the way across. And so, cleaning that up, I've got this multiplication, so d squared minus 2d minus 8. And from the top one, I've got the minus 7y. All right, so again, my quadratic equation, I get two distinct roots. Now, here, I don't know that these are the same constants as the first one, so I'm going to call them C3 and C4. Well, that's where part of the difficulty comes in. I can't have 4 different constants. They must depend on each other in a particular way. All right, so here is my original system. What did I do? I took the derivative of my x solution, so that's here, equals 4 times the x solution plus 7 times the y solution. All right, so now my goal is to match things up. So I've got a minus 7c1, and that matches up with this 7c3 term. So that gives me that c3 is really minus 1 times c1. And if I match up the e to the 5t term, I find out that c4 is 1/7 c2. So armed with that, I now get my final solution to my system in terms of c1 and c2 and the dependency between the two equations. Not hard, just long and messy. All right, in question 2, we proceed the same way. All right, everything's already on the left-hand side. So 2d minus 2x, where did that come from? Well, 2 times this minus 2 is from the minus 4. dy is there. In the second one, let's see, this is d minus 1x dy. All right, so I get my system of equations, messy right-hand side. So I want to get rid of the y's. So I simply multiply the second equation by negative 1. All right, at that point, the y terms cancel. I get an e to the t minus 6e to the t, giving me this minus 5e to the t. And this relationship for the x's. When I clean this up, 2d minus d is d, minus 4 plus 1 is minus 3. Well, what is that? That's not my second order problem. That's a first order problem. And so, looking at that back in terms of the derivatives, I see that this looks like something from section 2.3, where we had our integrating factor. So I'm focused on this piece, e to the integral p of t. My p of t is this minus 3. So I get a minus 3t. Here's the integrating factor multiplied by both sides. So on the right, I've got a minus 3t and this t, so a minus 2t. All right, continue cleaning this up. All right, we integrate both sides. Integrate this by substitution. I get a minus 1/2, making this a positive 5/2. And now divide through by e to the minus 3t. All right, and so what I see then is I get minus 2 minus a minus 3, so a positive 1t. And 1 over e to the minus 3t is e to the 3t. All right, so solving this for dy dt, I'm going to move everything to the right. So here's my forcing term, e to the t minus, so now it's a plus 4 times my x term minus 2 times the derivative of my x solution. All right, so cleaning all this up, what do I see? Let's see. Well, for the e to the t, I've got a 1 here. I've got a 10 there. I've got a minus 5 there. And now I'm putting together the e to the 3t terms. And so I get dy dt is this term. And integrating with respect to t, well, the integral of 6e to the t is 6e to the t. Integrate this term, I pick up a 1/3. And since I'm integrating, I pick up another constant of integration. But at that point, we're done. We have our x and y solutions to the system. All right, in question 3, extremely messy problem. All right, so first off, move, and it's messy because we have some initial conditions here. So here is our system. All right, so move everything to the left and get our differential operator here. D plus 11x plus y is 0, and do the same for the second equation. So my goal again is to get rid of something, and I want to get rid of the y's. I take d plus 1 times the first equation, and the second equation I multiply by -1. That gives me my equation for my second order problem factors into d plus 6d plus 6. It's a repeated term. All right, being a repeated term, I get x of t, c1 e to the minus 6t, and I get a c2 t e to the minus 6t. I go back to my system of equations. I would now like to get rid of the x parts. All right, so getting rid of the x parts. Let's see. This one will need a 25. This equation needs a d plus 11. D plus 11. All right, so here's the d plus 11 multiplied by both, 25 times the first. So the x parts go away, and I get a similar situation of repeated roots for the second problem. All right, so again, I get this problem of a C3 and a C4. All right, let's plug everything back in and see what is the dependency between C1, C2, C3, and C4. All right, so easy places to lose signs and numbers. Here's the derivative of the x solution equals minus 11 times the x solution minus the y solution. All right, so at this point, I just need to try to combine things that look alike. So I've got a lot of e to the minus 6t stuff, and I've got some stuff for t e to the minus 6t. I want to keep all the C3, C4 stuff on the right hand side and try to simplify the left hand side where I can match up pieces. And so I've got 5c1 plus c2 matches up with c3, and I've got this 5c2 to match up with this minus c4. All right, at that point, that gives me what my solutions look like in terms of C1 and C2. So I fill that piece of information in. Now I get my initial conditions into the game and see what does that mean. So when I plug in 1, I get this relationship for C1 and C2. Now supplementally, if you think about this, you can factor out a e to the minus 6, and you would get C1 plus C2 is 0. That's another hidden fact in that particular equation. All right, and when I plug in y of 1 equals 1, That makes things extremely messy. So we've got a second equation. So if you look at it in terms of these two things in stars that I have two equations and two unknowns in C1 and C2. All right, so I'm trying to get rid of the C2 pieces. So did that. Giving me what C1 is. So C1 is e to the 6. But we saw C1 plus C2 is 0. So C2 must be minus e to the 6. All right, plugging in what I know about C1 and C2. All right, so here's C1, here's C2. This is e to the 6 minus 6t, and I'd be left with a 1 minus t inside. All right, going back and figuring out what was y again. And now let's plug in C1 and C2. And after some cleaning up, I get a similar e to the 6 minus 6t. And I get a 5 minus 4, a 5t, giving us our two solutions for this system. So it may take you a while when you work this problem. There are a lot of small details. And in our last problem, we look at something from physics. We have a projectile shot from a gun, and so we have the forces that are acting upon this object. It's being shot from ground level, returns back to ground level. It has a velocity as it's moving. The only force acting upon it is gravitational force, so it's weight, mg. We look at Newton's second law of motion, which says the sum of all the forces acting on any point is equal to the mass times the acceleration. So if position is x of t, y of t, velocity is the derivatives, acceleration is the second derivative. All right, so we look at the forces acting on this object. The only force is downward in the y direction. And so in the y direction, my F in the y direction is m. Here's my acceleration in the y direction equals minus mg. So I can get rid of the m's. In terms of the x direction, there are no forces in the x direction. So I can solve this problem. This is easy, giving me x of t is c1t plus c2. In terms of the y direction, again, you can cancel the m's. You get y double prime, so the derivative is in terms of t, equals minus g. So integrate twice, I get minus 1/2 gt squared plus g3t plus ac4 because we were integrating 2 times.